Okie dokie. We'll be on in about 2 minutes. We'll start streaming in about 2 minutes. Well, streaming already, but start content in about 2 minutes. So one person online. If you pop your name in the live chat, remember the live chat is your register. All right. So if you just pop your name in the live chat, whoever you are. Seems to have lost the one person that was on. A bit worrying. But we'll start in about a minute. So as soon as you are on, pop your name in the live chat. So I know who's in. That is your register. Okay, so that's 10 o'clock by Michael. So pop your name on the live chat so I know who's on and who's not. And then we're going to basically go through whatever of these questions you couldn't do, which I do appreciate. They were quite challenging questions, I said. So I'm just going to wait on people to pop their names into the live chat. So I've got 2 people on at the moment, it looks like. Don't know who those 2 people are yet. Pop your names in the chat for me. So I've got 4 people now. So I've got Sheen, that's brilliant. While we're waiting for everyone else to pop their names in the chat, because that's very necessary. That is literally how register is going to be done. It's good morning to you. Hope you're well. Just so you know what you're going to need in general for this, I had a look at Google Classroom, and I'm not going to lie, I'm not massively. Hello, Zarif. I wasn't massively impressed by what they do. What I have got now is I can live stream my screen as well, so we can do things like Kahoots and stuff like that. So we can do that now, and we can do that on YouTube actually. So I'm going to probably do it there rather than Google Classroom. So what would you need for every lesson? Well, for this lesson, the only thing you're going to need is obviously the work that you've done, pen and paper, and the Pure 2 textbook, which is something that all of those things you should have. Those guys all have got like 5 people popped on at the moment. So if you pop your names in the live chat, that will be massively helpful. And then what I was just saying to everyone is that when you come to these YouTube live streams, make sure that you've got all your equipment ready. You'll need a pen, you'll need paper. You need to be able to use a it's good to see you. Good morning. Hope you're well. I hope your family's well. What you will need also is to make sure you're able to access the live chat. All right. Yep, I know you read up. That's fine. Don't worry. That's comfortable. Okay, so can I start asking you to start popping in the chat box what questions you'd like me to demonstrate from the work I set? So if you checked your email, which you should have done, because that was sent out about 5 to 9, I gave you an exercise to do for an hour, which was quite a, it was a pretty full-on exercise, let's be fair. And it would not surprise me in the least if people were struggling with it. Can I just reiterate to the point to those people that are on but haven't signed their name in, the register counts literally off the live chat. So as it stands in my lesson, as far as I'm concerned, Shiying, Kaisan, Rebat, and Zarif are the only students that are registered. If you've got problems getting online, that's a different matter, but you need to let me know that when your internet connection improves or through someone else or whatever. So can I ask you to pop in the live chat the questions that you couldn't do? Think Farhan is asleep, he gets marked late. I mean, just be careful on this. I'm going to reiterate what I'm saying. We're making decisions over the next month whether you stay on the course or not. All right? So you need to show like a real professional attitude. One thing I need to kind of really emphasize is like before I wasn't thinking like this, but before Easter, there might have been the thought in your mind, well, you know what? We're doing something new. We're doing something different. It's not serious. I'm as serious as coronavirus on this. I'll be honest with you, right? Now we're working, yeah? How have you ever struggled to wake up? Because I wake up every morning anyways. I mean, because we're so much locked up in your house, I know I'm not like some kind of super fit guy, but at least, you know, you do some exercise early in the morning, that'll keep you awake to science then. Do you know what I mean? It is just getting your routines, get yourself sorted. So it is what it is anyways. Right, so can you start popping in questions for me? Have a look at which you already should have done. It should be done, at this point, you should have done an hour's worth of work, right? What do you need help on in the questions that I set? What questions would you like to see demonstrated? And then I'll start demonstrating them for you, yeah? We've got so far Kaisan, Iman, Rebat, Zarif, and Shiying. And I'm going to do the register off that, but I'm also going to do the register on like whether you stay on the chat as well, all right? So you can't just type in your name and disappear. If you type in your name and disappear, you're marked absent, straight talk, right? It's serious now, right? The register hasn't even been done yet. The register is going to be done once I've seen you in the lesson for an extended period of time. So it's not just going to be 1 minute and people disappear. 3B. Okay, we'll start with 3B. That's a good place to start. So in the very, very hopefully unlikely event that you haven't gotten started on this, and you really ought to have done, there's no excuse not to have done. Okay, given that K is, and it doesn't say exactly what, and that's a bit awkward, so that's a bit of a weird one. Show that the integral of this is inversely proportional to K. So we need to be able to integrate that thing. So that's, I'm just going to pop it on there. I don't know if you can see that well. I'll check in a minute. So it's between 3K and K. So no, it's not 3K, it's 2K and K. 2K, 2x minus K squared. All right? So I don't know if you can see the squared all that well. So first of all, what we need to decide is how is that going to be? Yeah, I mean, I'm not expecting you to be there. Like, obviously, in that situation, you have to just do your best, right? But I expect you do your best, if that makes sense. That's all I can ask. It's the same thing I'll say to every single student I've got. If there's issues, do your best. That's all you can ask, right? You made more of an effort than Fohan or Marilla, for that matter. Anyways, okay, so what kind of integral is this, right? This integral is not one of those, you know, ln ones, because obviously you differentiate to 2x all squared. Kelvin, good to see you. All right. What we're doing 3B from the classwork that I set. This is 3B you're looking at. This is very much one where you have to split this up into the form A over 2x minus K, and then B, I don't know if you're going to see, so I'm going to put it down here. B over 2x minus K. And then you've got to do something a bit weird with this. It's sort of like, I need to show you this really, I think. So let me do that. So what I'm going to do is I'm actually going to do the algebraic long division, the partial fractions of this. So excuse the integral for a minute. Let me just turn it into partial fractions first, and then you can see how to handle integrating it. So what you had was 2 over, let's quickly check the exact formation of this, 2x minus k all squared. And the way you deal with that is you've got something here called a repeated factor, which is 2x minus k because it's squared. So you can't immediately just go, okay, it's going to be a over something, b over something. What you do is you go, okay, this is the same thing as saying, let's a 2x minus k, and this is not, they're not equal, that's why there's not an equal sign, but this is the method you use. You do that, all right? So that's what happens when you've got something that's got a squared or a repeated root at the bottom of the algebraic fraction, or the partial fraction. You write it like this. If you cross multiply, you now get and you're going to say, and you're quite right to say it, that, hold on a minute, this thing and this thing are not identical. And you're quite right, they're not. The denominator, this one's got 1 extra 2x minus k. Nevertheless, that's your steps for now. These two are not equal yet, but we're able to do something in just a moment to sort that out, which is just cancel through by 2x minus k. So we'll see if I've got space. I've got space here. Yeah, okay, cool. So it's going to be, I need to sort this out. A 2x minus k plus b all over 2x minus k squared. All right? At the end of the day, we're going to turn this into that. Yeah? We're going to turn this into that. I've just realized you don't need to do that. There's too much force. I mean, yeah, I'm sorry about that. You can do this, and this isn't wrong, but surely I could just do chain rule. I'm being really stupid. I'm sorry about that. That wasn't the cleverest thing I've ever done in my life. Chalk that up to kind of me just being a bit silly there. Could I not just go, this is 2. What was the thing again? 2x minus k, and what's that squared? So wouldn't that be an example just straight of that just being f dashed of x, fn to the x? And that would be just so much quicker than the garbage I was going to do. Do you remember that thing where you can basically say, if your integral is in this form, the thing you want to integrate looks like this, the answer is just going to be f of n plus 1 to the x with some correction. Are you familiar with that? So I feel like I've talked for a few minutes there. So what I'm going to do is I'm just going to finish this. Then I'm just going to ask you if you understood what I did. So basically the answer for this one, I would say my guess would be, so that should be my minus 2 there. You raise up the power by 1, so it'll be 2x minus k to the minus 1. Do chain rule on that, so you get a 2 there. So that's du dx. The dy du, use them as 1 minus 2. So you'd be what, minus half there? Plus c? All right, here's a challenge for you. Can you differentiate what I've just put there and show me if I've got the right thing for this? All right, so that's your challenge. And if you don't understand where I got that from, so how I got from the integral of this is that, pop in a chat box. I think that's definitely the fastest way now I see it. All right, so pop in a chat box either yes or no. For yes if you understand it, no if you don't. And if you don't understand it, can you put with the no what you don't understand? If it's the whole thing, literally say, I need you to do this step by step slowly. I'm just going to check. No? Yes, you think you do? Brilliant. Okay, cool. So I'm definitely going to do it. Because at least one person is saying no. So first things first, the question asked me to integrate this. Yeah? Is it 2x minus k squared? So that's what it wants me to integrate. Let me just pop that so you can see that a bit better. So I'm going to write that as saying that's the same thing as, all right, rebut. Can you just check that I've got my sums right then for you? So your job is literally just to make sure I haven't screwed up somewhere, because I was going to do something really hard to do something very, very simple. Yeah, so that's that. All right, so all I've done is rewritten this as that, and I'm going to write that a bit more neatly. I need to get a thinner pen. So that's going to be 2x minus k, and because it's squared at the bottom, let me just clear all that garbage out of the way there. That's going to be a minus 2 there. So I'm hoping that's making sense to you. So that's where we're starting from, right? And there is a rule that says if the thing you're trying to integrate looks like this. So let's talk about what this means. So basically, if you could, sorry, I really need a proper board right here. If you differentiate 2x minus k, not the power, just the 2x minus k, you'd get 2. So it's sort of kind of, if you differentiate f of x, you get f dashed of x. So it's in that sort of same form, yeah? We're disregarding the power, yeah? And the rule says that if you have something that looks like that and you want to integrate it, the formula, so your guess should be the same thing, so this guy here, but 1 power higher, okay? That's the rule for it. That's the logic, yeah? Write that down if you didn't know that. And what I'm going to do next is demonstrate how that rule works. I definitely need to change up this pen. It's way, way too thick. This is not the right pen for this job. We've got 9 people. Wow, I don't know who these people are. Okay, cool. Fine, good. And then you're in. At least you won't be marked absent. That's something. Right, okay, cool. Here's what we're doing. What I said was it plus C as well? What I said to you just a moment ago was, if this thing is in that form, my guess to start will be the same thing with 1 power higher. So this would now be 2x minus k to the minus 1 plus c. That's my guess. All right, we're going to have to check our guess. So let's go through the steps quickly. First of all, we rewrote it like this. We noticed if you differentiate what's in the bracket, you get what's on the outside. So that gave me the hint I could use this formula here, which says that if you're integrating f dash of x and f of x to the power of something, a good place to start is not the final answer, and I'll show you that in a minute, but a good place to start is that thing 1 power higher. So here we're on minus 2, 1 power higher is minus 1. So this is going to be our guess, all right? So our guess is minus 2x minus k to the minus 1, and we're going to differentiate that and see how good of a guess it was, all right? So I'm going to rub out the middle step now, all right? Okay, and again, hopefully taking notes at each time, yeah? So we're saying our guess right now is that we're going to go with 2k, so 2x minus k to the minus 1 plus c. Let's do chain rule on that. Yeah, let's do chain rule on that and see how good of a guess is it. Do we come back to here? Well, let's find out. So we would go that u equals 2x minus k. And if you differentiate that, so du dx, you just get 2. Y would be u to the minus 1. And if you differentiate u to the minus 1, you're going to get dy du is minus. So what are you going to get there? Minus u. So I was wrong on that. So there was a slight mistake on that. So minus 2. Yeah? So my last answer was slightly off. So I forgot what I was doing with that. You times those two things together, dy du and du dx, and you get minus 2. So you get dy dx is minus 2 u to the minus 2. All right? I'll move that so you can see that a little bit better. Remember, dy dx is dy du du dx. And that's minus 2x minus k to the minus 2, which is almost right. The sign is wrong. It should be a positive there, not a minus. So if I put a minus here on my guess, it will cancel it out, and that gives you your final answer. So it wasn't a half at all, it was just minus. Yeah, so I put minus a half when I did it like first time. So that's where the thing, yeah? Right, so hopefully that makes some level of sense to you. Okay, so the big idea is that if you've got something in a bracket to a power, and then in front of it, you've got something that's the bracket differentiated, your best guess is to take that bracket, raise it up by 1 power, put a plus c on the end of it, and then differentiate back down to see how wrong you are. And then however wrong you are, so for me, the only thing wrong with what I did, I had a minus where it's a plus there, so I put a minus sign on my final answer to get it. What does the inverse proportional part mean? Well, I don't know if you guys did this at GCSE. It used to be a very, very common thing. Anything over x, so like 3, sorry, other way around. No, it is that. Can I at least rub this? If you could write this formula, so let's say a is something over x, that means a and x are inversely proportional. Do we need to? No, I don't think so, unless I've screwed it up. If you look at what you get, what you should get for your dy dx is minus 2. This is what I got, unless I made a mistake on it, which is entirely possible. Minus 2x minus k to the minus 2, and that's only minus 1 off. Is the integral the final answer? No, you'd substitute the k's in. Yeah? And then hopefully you're going to get something in terms of that sort of the relationship. So let's have a look at the relationship. So it wants to show it's inversely proportional to k. So you'd want to get k, you'd want to get something over k as your final answer. Yeah? Let's have a look at that. So once you've got the integral, which you should have now, So I do apologize. Once you've got the integral, you substitute your values in, and you should get some value for k. I know actually, if you look at the answers, they've done it a slightly different way as well. But then again, the question they've set seems to be different. That's a bit weird, isn't it? 3a. No, they've done what I've done. Sort of. They've done something quite weird. But yeah, you should get something over k. All right. So that does make some level of sense to you. Let's have a look at what people are saying, whether they make sense to you or not. So again, comment in the chat box by all means, whether it makes sense to you or not. But you should have some integral in terms of k. So pop up in the chat box anything else you want to see. And I suspect there should be a fair bit. If there are people, and I really wouldn't be happy, k belongs to what? K is just a constant. Oh yeah, that's a fair shout. I would just run k as an integer. I don't have the answer to that either. Just run k. K is just a thing. It doesn't matter. I mean, it's a shame it's not come off on the sheet properly, but you know, it's not something that actually will affect the question unless it starts becoming complex. But you know, in this class, with me, you never have to deal with such things. So don't stress about it. It is annoying. I appreciate that. I saw that. I wasn't happy about that. What else do we need to see? What else do we need to see? We've got about 10 minutes. What else do we need to see? So you should be looking at the pack. You should have done an hour's worth of work on this. And I have a feeling that some of you haven't. Let me see if anyone sent me pictures of it. Yeah, can you send me pictures to show me that you've done these, at least some of these questions on Microsoft Teams for these? Because as I said to you, take these lessons seriously now. This is going to be your life for at least a month, I would say, realistically, probably more than that. So if you start kind of like, we start wasting time, we're not learning anything, then you're going to be in big trouble next year. Let's be real. Whether you survive the first year course or not, that's one matter, yeah? So your proper end of year exams are going to be in September, so that's going to be one thing as well. But even to like make sure that you pass the exams at the end of the second year, you need to be full on, you know, you need to treat them as if like I was in the class with you and we're all sitting in class, right? And this is not going to improve the situation. At least I would say if we're back in June, I would say like God has blessed us. I said take it seriously. Make sure if I'm saying set a work from 9 to 10, you need to do the work between 9 and 10. And then if I say send me the pictures, send me the pictures. So make sure that you've sent me pictures of your work. I'm waiting for those. I'm looking at my I'm on my phone now looking at trying to just wait for that. Okay, can you put some questions in the chat box about what else you want to see from that? So have a look at the questions I've set you. What else do you need help with? So what I'm waiting for people to do is just pop up in the chat box. Hopefully send in pictures, that would be handy. And also ask any questions you want to see done from this pack. I'm still waiting on that. I see what people have done what. Okay, so that's slide 53. Okay, just give me a second to pop that up. Be happy to. What I'm going to do, I have got the ability to live stream my screen now, but it's hard to switch between that and this. So what I'll do is for this one, I'll just write it on the whiteboard. But we will be able to do things like Kahoots and stuff now, so I know how to do that. Right, so 53. Thank you for the organized way you asked that question as well, so I know exactly what you want me to do. That does help big time. Right, so 53 is. Thank you. Didn't ask you for nonsense. Don't do that. Just bear with me a second, it's taking a little longer. Thanks for this thing. Okay, 47, 48, 49, 50, 51, 52, 53. Okay, so that's a trapezium rule question. And it's given us this monstrosity. So let's have a quick look. It says, so just bear with me. Stupid thing sometimes. The integral here is between pi over 3 and 0 sec x dx. You want to find the exact value of I, first of all. So, for part A, it asks you to find the exact value of that. There's two ways around doing that. First of all, you can just blast it on the calculator. Second of all, you can use the fact it's in the formula booklet. Either way will do you. If there's an interest to find out how to integrate sec x, let me know, drop something in the chat box, and I can start off next lesson's live stream by showing you how to integrate sec x. I mean, it's a shout. But to be fair, it's not necessary. So you literally just plug it into calculator, and the value you'd get is, just bear with me a moment, I'll tell you. Ln 2 plus root 3. And the only reason I'm not bothering to demonstrate that is there's no point, right? Because you'd expect it to use your calculator for that. And you wouldn't be many marks either. So if you want two strips for part B, so this is slide 53, if anyone's just wondering what the hell I'm talking about. So slide 53 on the PowerPoint I sent to you. You need three numbers. And they've told you it's between 0 and pi over 3, so I'm going to go with x is going to be 0, pi over 6, which is halfway between 0 and pi over 3, and pi over 3. Substitute those numbers into sec x, yeah? Into sec x. And you get about 1.115, apparently. 155, my apologies. And 2. All right? Then you plug them into the formula. And the formula is given on the top of the slide. And it's just to reiterate what it is. It is a half times the gap in between each number. So it's going to be pi over 6 times the first number and the last number and 2 lots of the middle number, because you only got 3 numbers. And then if you solve that, pretty simple. Yeah? The only difference between B and C is you've got to do, it says for 4 strips, so you're going to need 5 numbers. So again, you're splitting the difference between pi over 3 and 0 into 5 parts. And the way they've done that, it's got to be equal sizes. So they've got 0, pi over 12, pi over 6, pi over 4, pi over 3. And the reason why they've done that is really just because it's 0, pi over 12, 2 pi over 12, 3 pi over 12, 4 pi over 12. And they just simplify the fraction. And then they plug those back into that same formula. The percentage error, you do by calculating the difference between basically how wrong you are, yeah, divided by what the actual value is, times by 100. Remember we did that formula before. Is there anything else you need to know on that one, Iman? You want to know about pi? Yeah, okay, cool. So do you actually want to see it done? Do you want me to integrate sec x? We're heading towards half past. So maybe when I'll start the live stream again at 45. I'm quite happy to integrate sec x for you. Is that what you secretly want to see? It's not secret. I mean, it's not very exciting either. So pop something in the chat box of what you want to see for that. So just for the rest of you guys, I'm looking at the teams. Yeah, cool. We'll do that. The only one who sent me any work as it stands is Reba. So this is garbage. I'm not satisfied with this. Yeah? The register is going to get done, but as I said, I'm going to do it at the end because I'm not happy with how this lesson has progressed. I'll tell you for 3 reasons, right? Number 1, I set work at 9 o'clock. The only person it appears that's done any of it is Reba. Yeah? That's a shambles. As I've said to you already today, lessons need to be taken seriously, right? And that's because, first of all, we're making decisions about whether you stay on the course. And second of all, because if you take a 3-month holiday and then you have a summer holiday, you will fail your A-level. You'll flat out fail, right? So if I'm going to say do work from 9 to 10, it needs to be done between 9 and 10. And if you can't do it, I need to at least see pictures of where you've kind of, you've tried. Because it's a fair shout that you're struggling. Okay, fair dues, right? But I need to see some work and I'm not seeing it. That's not good enough. Yeah, exactly. Send me those pictures then, right? So then when I'm going to put, when I have to do things like course of concerns, I'm like, oh, okay, Iman did it, Rebut did it, no problem, right? Because they're going to ask me sooner or later, do you think these people should carry on the course? If you ask me from today, you two are the only people that deserve to be on there because the work's not done. There was an email set at 9 o'clock. You guys are bringing it to 10 o'clock. That's a different level. What else am I going to say to you? I'm also going to say to you what we're going to do for the next rest of this lesson. I'm going to shut this stream down in about a minute or so. I'm going to pop back up. It's 31, so I'm going to say about 50. 10:50 is when I'm going to pop up. What am I going to do in that time? I'm going to show you how to integrate sec x, and I'm going to start differential equations with you. All right? I would like to see in the next 15, 16 minutes pictures of your work done if you've done work. And if you haven't done work, there's going to be something to say. I'm also going to check your Dr. Frost maths during the next PowerPoint as well. So next live stream as well. All right. Register will be done after the second live stream to make sure that everyone's staying in class. Right. Not messing about with any of this stuff. All right. Okay. So I will see you again at 10:50. All right.